Welcome to the Explainer. Today, we're going to do something a little different. We're going to crack the code of a single complete exam question. By breaking down question 5 from an AQA GCSE Chemistry paper, we'll show you how to think like an examiner and how to lock down every single mark you can.
All right, so here's our game plan for this question. First, we'll decode the data they give us. Then we'll tackle pollutants and environmental impacts. After that, we're going to master a pretty tricky gas calculation and unpack the entire process of distillation. And to wrap it all up, we'll pull out the key takeaways you can use in any exam. Let's get into it.
So, let's set the scene. This whole question is about the fuels we use for our central heating. It's putting two options head-to-head, hydrogen versus good old natural gas, which is mostly methane.
Okay, the examiners give you this table right at the start, and you've got to pay attention to it. This data is absolutely crucial. It holds all the evidence you're going to need to unlock the answers for a bunch of the questions later on, so get familiar with it.
Right, let's jump into the first part of the question. This bit is all about testing our knowledge of the nasty pollutants that get formed whenever we burn fuels.
So, the first question wants us to explain how these pesky oxides of nitrogen get made. Now notice it's a 2-mark question. That's a huge clue right there that we need to make 2 separate, correct points to get full marks.
And look at the precision you need. This is straight from the official mark scheme. The first mark is easy enough, just for saying high temperatures. But for the second mark, you have to be specific. You have to say that nitrogen from the air reacts with oxygen from the air. Just saying nitrogen and oxygen react is probably too vague, so be careful.
The big takeaway here is you've got to be laser-focused. Examiners are only looking for one thing: the direct link between the crazy heat of burning the fuel and the reaction of the gases that are already in the air. Don't waste time adding extra details like pressure. It won't help.
Okay, on to the next part. Another explain question. This time they want a positive environmental impact. And look, the question is literally telling you where to find the answer. Use the data from Table 2.
So here's what a perfect answer looks like. For your first mark, you identify the positive impact, like less climate change. And you can see the mark scheme also allows less global warming, which is nice. Then the second mark comes from using the table to explain why. It's because no carbon dioxide is produced. Simple as that. Now this, right here, is a super important exam technique for any question that asks you to explain. You can't just throw out 2 random facts. You have to connect them. The absence of CO2 is the cause, and less climate change is the effect. Making that logical link is what gets you that second mark.
So, let's keep going and see how this all builds. You know that every fuel has its pros and its cons, right? Well, now the question flips it on us and asks about the negative side of burning hydrogen.
See, it's exactly the same style of question, just looking at the downside this time. We need to hunt down a negative impact. And once again, the evidence is just sitting there waiting for us in Table 2.
If you look closely at the data, you'll see hydrogen actually produces slightly more oxides of nitrogen. Stating that, boom, that's your first mark. For the second mark, you have to explain the environmental problem this causes, and you've got options. You can say more acid rain or more respiratory problems. You can even mention specific effects, like damage to buildings.
Now this is absolutely crucial. Think of your answer like a chain. It has to be logical. If you get the pollutant wrong for the first mark, you cannot get the second mark for its consequence, even if that consequence is right on its own. The whole answer has to hang together and be scientifically correct.
Okay, time for the part that sometimes makes people a bit nervous, the calculation. But honestly, don't panic. These questions are always designed to be broken down into simple, logical little steps.
See, a 3-mark calculation is really just 3 small steps, and you get 1 mark for each. Step 1. You use the 2-to-1 ratio from the chemical equation to figure out the volume of oxygen you need. That's 1.75 decimeter cubed. Step 2. You scale that up to find the volume of air. We know air is about 20% oxygen, so we just multiply by 5. Which brings us to Step 3, our final answer, 8.75 decimeter cubed.
This might be the most important tip for any calculation in your entire exam. Examiners use something called error carried forward, and it's a total lifeline. It means if you mess up Step 1, but then you use your wrong answer correctly in Step 2, you can still get the mark for your method. This is why you must always show you're working. It's your safety net.
All right, for the final part of the question, we're doing a complete 180.
We're shifting gears from combustion and moving over to crude oil to tackle a 3-mark explanation of fractional distillation.
The key word here is how. The question asks how kerosene gets separated. This is a process question, so the examiner isn't just looking for facts, they're looking for a clear, logical story. 3 marks means we need 3 clear scientific points in the right order.
So, what's the 3-ingredient recipe for a perfect answer? Well, here they are. First, you have to mention the temperature gradient in the column. You know, how it's super hot at the bottom and gets cooler as you go up. Second, you must use the scientific keyword condenses, because the vapor is turning back into a liquid. And third, you have to link that condensation to kerosene's specific boiling point.
And there you have it. You can see how those 3 marking points just flow together to create a perfect, concise answer. It's a logical sequence, it uses all the right scientific language, and this is exactly what a top-scoring answer looks like.
So, we have completely dissected question 5. What are the big picture lessons here? What can we take away from this that will help you in the rest of your exam?
Think of these as your golden rules. Seriously, be super precise with your scientific words. Always show you're working in calculations to grab those method marks. Always link cause and effect when a question asks you to explain. And finally, actually read the mark schemes. They tell you exactly what the examiner wants. These rules are your key to success across the whole paper.
And I'll leave you with a question to think about. What's your fractional distillation? What's your gas calculation? What's the one topic that gives you that uh-oh feeling? Figuring out what worries you is always the first step to mastering it. If you apply the techniques we've talked about here to those areas, you can absolutely turn any weakness into a strength. Thanks so much for watching.